Hey everyone, so today we are talking about chemical conversions. So this is very much just like dimensional analysis, right? Feet per second to miles per hour. But now we're just doing things where we are changing grams to moles, moles to molecules, molecules to atoms. It's all just one level on our multiplication dot fraction bar. It's not like a top and bottom like we did with feet per second to miles per hour. It's just one pretty simple conversion. Now grams, we know what grams are. Grams is how we measure the mass of something. If I have 5 grams of iron, I probably have a little block of iron. But what are moles? Moles is just like when I say a dozen, you know I'm talking about 12. Well, 1 mole is actually 6.022 times 10 to the 23rd molecules. Okay, and you might be asking, okay, why do we do this? Why do we say 1 mole? Well, if you're talking about a lot of molecules, it's a lot easier to say 1 mole than it is to say 6.022 times 10 to the 23rd molecules. Okay, when you're talking about all the air in a room, I could say 5.066 times 10 to the 46th molecules, or I could just say something like 25 moles. All right. So if I had a mole's worth of donuts, it'd be 6.022 times 10 to the 23rd donuts. But in this case, we're just talking about molecules. All right. So we're going to be converting from grams to moles, which again, if it's just 1 mole, it's just 6.022 times 10 to the 23rd molecules. And then we'll go from moles to molecules, and then we'll go from molecules to atoms, which I'll talk about later. So, the first thing we are going to do is let's start with grams, and let's go to moles. So I'm going to create this nice little chart that at the end you can use to do these conversions with. So I'm going to put that up here. So first things first is we're trying to go from grams to moles. Okay? If you want to go from grams to moles, you're just going to divide by molar mass. And then if you want to go from moles to grams, you're just going to do the opposite, which is multiply by molar mass. So let's do an example of that so this kind of makes sense. So say that I have 23 grams of carbon, and I want to convert that to moles. Okay? 23 grams of carbon, I want to convert to moles. I'm going to divide by the molar mass of carbon. So, I'm just going to write down 23 grams of carbon. I'm going to divide by the molar mass of carbon, which if I look at my periodic table, remember the molar mass is the number that is underneath the chemical symbol. So for carbon, it is 12. Remember the symbol for molar mass is grams per mole. And this is good because if I look at my units, right, grams are going to cancel out and moles is going to go on top. So this means I have 1.92 moles of carbon. Okay? Which just means I have about 1.2 times 10 to the 24th molecules of carbon. But it's just so much easier to say 1.92 moles. It makes the numbers a lot more digestible. Let's do another one. Say I have 8 grams of O2, and I want to change it to moles. Okay? Once again, we're going from grams to moles, so I'm going to divide by molar mass to get to moles. Start with what I'm given, which is 8 grams of O2. The molar mass of O2 is 32. Oxygen is 16, but since I have 2 oxygens here, I gotta divide by 32 grams per mole. Grams cancel out, left with moles. And that is going to be 0.25 moles of O2. Okay? Instead of saying 1.5 times 10 to the 22nd molecules, I'm just saying 0.25 moles. Okay, now what about if we wanted to go from moles to grams? Okay, say we wanted to go from moles to grams. So let's say I have 0.67 moles of, let's go with C2H3. And I want to go 2 grams. So, again, we're now at the moles, but now I'm going to grams. So instead of dividing by molar mass, I'm going to multiply by molar mass. So I start with what I'm given, which is 0.67 moles of C2H3. I multiply by the molar mass of C2H3, which carbon is 12, hydrogen is 1, which if we add all those up, those 2 carbons and those 3 hydrogens, I should get 27 grams per mole. You could write it as MOL if you want. I write it as MOL every now and then. That's okay in chemistry land. And look at that. I got moles on top, moles on bottom. They'll cancel out, and I'll be left with grams, which gives me roughly around 18 grams of C2H3. Okay, so grams to moles and moles to grams we should have down. But now, let's go ahead and take this a step further. Let's say that I no longer want to know how many moles there are, but now I want to know how many molecules there are. Well, remember that I gave you that nice little conversion that 1 mole equals 6.022 times 10 to the 23rd molecules, which this number is known as Avogadro's number. Okay? Avogadro's. Some of you will say avocados. That's fine. Just know it's known as Avogadro's number. Okay, that's 6.022 times 10 to the 23rd. So when we are going to do conversion from moles to molecules, when we're going from moles to molecules, we multiply by Avogadro's number. When we're going from molecules to moles, we divide by Avogadro's number. Okay? So, again, if you want to go from grams to molecules, you just divide by molar mass, multiply by Avogadro's. If you want to go from molecules to grams, you just divide by Avogadro's and multiply by molar mass. Let's do a couple where we're going from moles to molecules. Let's just say that I have 3.3 moles of O2 and I want to go to molecules. Pretty straightforward. We start with what we're given, which was moles, so I'm right here on my little chart, and now I'm trying to go to molecules, so I'm going to multiply by Avogadro's. And I'm going to use my units because you know I love units. Right? I use my multiplication dot fraction bar. Moles on bottom, molecules on top, which I will abbreviate as MC. And I know for every 1 mole, there are 6.022 times 10 to the 23rd molecules. That works out really nicely because now my moles cancel out. I'm left with just molecules, and you should get 1.99 times 10 to the 24th molecules of what we start with, O2. Okay, so again, moles to molecules, we just multiply. Let's go from grams to molecules. Let's do a little 2-step equation here. Let's say I have 88 grams of CO2 and I want to know how many molecules that is. Okay. We always start with what we're given. We're starting with grams and we got to go all the way to molecules. So again, let's just start with what we're given and go from there. I can't just go straight from grams to molecules. I got to get to moles first. So what I'm going to do is I'm going to divide by molar mass. The molar mass of CO2, carbon is 12, oxygen is 16, so that should be 44. So I'm going to divide by 44 grams per mole. Grams cancel out. I'm left with moles. Hey, my units are looking good. I got 2 moles of CO2. But again, I don't want to stop at moles. I want to get to molecules. So now I'm going to multiply by Avogadro's number. Remember, for every 1 mole, that means I got 6.022 times 10 to the 23rd molecules. And I'm going to plug this into my calculator. I know it's like 1.2044 times 10 to the 24th, but I just want to make sure. Yep. 1.2044 times 10 to the 24th molecules of CO2, which means I got 1.2044 times 10 to the 24th molecules of that guy right there. Right, and then let's just do one where we go backwards real quick from molecules to moles, just so we take care of the whole thing. So let's go ahead and let's say that I got, let's do 7.88 times 10 to the 23rd molecules. Again, I'm just abbreviating it as MC. 2 moles. I'm not going to tell you what compound this is because it doesn't really matter for this step. So again, we are start with what we're given, which is molecules, and we're trying to go to moles, so we're going to divide by Avogadro's number. 7.88 times 10 to the 23rd molecules. I'll put molecules on bottom, moles on top. For every 1 mole, there's 6.022 times 10 to the 23rd molecules. Molecules cancel out. I'm left with moles. I know I'm on the right track. I go ahead and I do that, and I should get something like 1.31 moles. See, that is so much nicer just to say 1.31 moles instead of 7.88 times 10 to the 23rd moles. Alright, so now we should be good with going from grams to molecules, or molecules to moles to grams, or moles to molecules to moles, so on and so forth. You should be good. Now we got one more. Now, remember, molecules are just a compound on its own. But now we want to know how many individual atoms there are in a compound. So now we're going to go from molecules to atoms, and vice versa. And all it is how many numbers of atoms are there in that molecule. We'll either multiply if we're going from molecules to atoms, or we'll divide if we're going from atoms to molecules. Now, what do I mean by number of atoms? Well, let's look at a couple examples here. If I look at CO2, remember, atoms are just elements. How many atoms are in CO2? Well, there's 1 carbon and 2 oxygens, so there are 3 atoms. How many atoms are there in O2? 2 oxygens, 2 atoms. What about C6H12O6, which is sugar? How many atoms are in that? 6, 12, and 6, there are 24 atoms. So for our last step, when we're going from molecules to atoms, we're just multiplying by how many elements there are in our compound. So let's go ahead and do another example like that as well. Say I got an Avogadro's number worth of CO2 molecules. And I just want to go to atoms. Okay. First of all, I start with what I'm given, which is molecules. So I'm starting right here in our nice little chart. And I'm trying to go to atoms So I'm going to be multiplying by the number of atoms of whatever compound I'm talking about. And in this case, compound I'm talking about is CO2. For every 1 molecule of CO2, there are 3 atoms. 1 carbon, 2 oxygen. So I'm just multiplying by 3, and you should get something like 1.81 times 10 to the 24th atoms. Let's go backwards. Okay, let's go ahead and go backwards. Let's say I have, let's say I have 2.0 times 10 to the 28th atoms of, let's go with CH4, and I want to go to molecules. Okay, so once again, I'm starting with what I'm given, which is atoms, so I'm all the way over here, and I'm trying to get to molecules, so I'm going to divide by however many atoms there are in my compound. Right, so I start with what I'm given. I'm going to have atoms on bottom, molecules on top. For every 1 molecule of CH4, there are 5 atoms, right? 1 carbon, 4 oxygen, or 4 hydrogen, sorry. Atoms cancel out. Should be 0.2 times 10 to the 28th. Let's see. Oh, I was off. That's okay. 4 times 10 to the 27th. Molecules of CH4. Right, I was at atoms, I divided by 5 to get to molecules. Alrighty. Now let's do one all the way across the board. Let's go from grams all the way to atoms. So let's say, I don't know, let's just say I got, let's go with 50 grams of H2O, and I want to go to atoms. 50 grams of H2O is 50 milliliters of H2O. Let's start here, move all the way down. So once again, I start with what I'm given, which is 50 grams of H2O, and I'm trying to get to moles, right? I can't just skip all the way to atoms. I got to go through each little step. So I'm going to divide by molar mass, which we should know of water is 18. Grams cancel out, I'm left with moles. So 50 divided by 18 is, I'll simplify it to 2.78 moles of H2O. Now I'm here, I gotta get here, so I better multiply by Avogadros. For every 1 mole, there's 6.022 times 10 to the 23rd molecules. Moles cancel out. So let's go ahead and take 2.78 times 6.022, second e to the 23rd. I'm going to move it down here, so I got 1.67 pretty much, times 10 to the 24th molecules. So now I'm here and I'm trying to get to atoms. How many atoms are there in 1 molecule of H2O? 3. 2 hydrogens, 1 oxygen. So I just multiply that 1.67 times 10 to the 24th, times it by 3, and you should get something like 5.01 times 10 to the 24th atoms. And there you go. That is molecular conversions. Feel free to write this chart down and use it with these. Make sure that you are able to get away from this at some point and just have this down by using your units. But that is it for chemical conversions. If you have any questions, let me know, and have yourselves a great day.